Hello everyone. We'll now move on to the application of the formula which we derived in the video earlier on. I'm going to use this example to show you how to apply the formula, and also concurrently I'll demonstrate to you why in the context of household electricity we prefer to present our energy consumption using kilowatt hour instead of joules. First of all, let's go through this example. Now, an air conditioner has rated values 12 ampere and 240 volts. What does rating means? It merely means that the air conditioner requires a voltage and potential difference across 240 volts, and when there's 240 volts across the terminals, then 12 ampere will flow through the air conditioner, and this will allow the air conditioner to function as per normal. Now, this air conditioner is switched on for 8 hours per night and 30 days per month. We require to calculate the energy consumed in joules and in kilowatt hour. Well, they are essentially the same thing, okay, just presented in different format, and I'll go through with you now. Now, if I were to calculate the energy in joules, you use the formula E equals IVT, which is what you derived earlier on. Now, I is actually your current, and the SI unit is ampere. V is actually your potential difference, and the SI unit is in volts. And T is actually your time, and the SI unit is actually in seconds. Now, as derived earlier, IV is actually power, and the SI unit for power is watts. So essentially, you're taking power in watts times time in seconds, and that's how you get joules, energy in joules. So E equals IVT. You take current 12 ampere, plug it in, 240 volts, plug it in. Now time. 8 hours per night, 30 days per month. So you take 30 days times 8, and that gives you actually the total number of hours per month. But you need to calculate the time in seconds. And 3600, by now you should know, is actually the time in seconds. So there's actually total number of seconds per hour. So what we have here, 30 times 8 times 3600, is actually the total time in seconds for these problems. So total time in seconds for this problem. So if I were to take all the numbers and multiply together, I actually get 2,488,320,000 joules. Now that's quite a mouthful, right? And the number is very large. Okay, and that's only using one appliance. Kind of scary. But using the same formula, but this time around, I want to present the energy in kilowatt hour. Kilowatt hour. So kilowatt, this is actually power. Hour, this is actually time. So what happens is, my time, I just have to calculate time in hours. And IV, I just have to calculate my power in kilowatt. So if 12 times 240 is actually in watts, and that's why now I divided by 1000. Divide by 1000, I actually convert watts to kilowatts. So essentially, this whole thing here is actually in kilowatts. How about time? So 8 hours per night, 30 days per month. So essentially, that is actually total number of hours per month. You will take 30 times 8. So actually, this is total time in hours. And hence, when I multiply together, I will get 691.2 kilowatt hour. Right. So you see that when I present my energy in kilowatt hour, the number looks smaller and, well, in a way, more presentable. So from the above solution, you can see that presenting in kilowatt hour actually makes the number easier to read. And energy in kilowatt hour is usually seen in your electricity bills. Well, if you have not seen your parents' electricity bills, well, get it from them and take a look at it. All energy in there are presented in kilowatt hour.